Hi all, welcome to our channel GIL Qubit Minds. Today I will discuss on quantum computing. This is our first video and we are planning to make more videos on quantum computing. So let's get started. So basically we understand the classical computer or laptop that we work in our office or in business. So we know about classical computers, how it works, but how the quantum computer works, it is a new era of quantum era, we can say. So there is a mechanics, quantum mechanics or quantum physics, which is the working principle of quantum computer. So we know every day all the objects that are surrounding us, they're following the principle of physics. But when we are going into the atomic and subatomic levels, it's work differently. So that working principle can be defined by quantum mechanics. So the quantum mechanics also, we know that it has bring lots of benefits in various area, like researchers has invented transistors, lasers, also developed nuclear power plants, also explained all the superconductivity with this quantum mechanics. And nowadays this quantum computer is built on top of this quantum mechanics. So this quantum computer, we know that follows the principle of quantum mechanics. It uses qubits, quantum bits. So unlikely the normal computer or laptop, we call it classical here, classical computer, it's only can exist on a particular time 0 or 1. Only one bit is possible, either 0 or 1. But in quantum computer, 0 and 1 can coexist simultaneously they can exist due to the superposition and entanglement. We'll see how superposition and entanglement works in later videos. This 0 gate and 1 gate, or 0 bra 1 bra, this is the this is how the diag notation works to denoting the quantum bits. So this is the column vector and this is the row vector. So we'll also explain this at a point of time. And finally we can see this quantum computer generally works in very extremely cold temperature. It is minus 10 to 15 millikelvin, or we can say minus 273.14 degrees Celsius. Well, now we know that lots of research is going on, but in 1982 Richard Feynman is the pioneer of quantum computing. He first proposed that the quantum system could be used for computing. Then David Deutsch, he also done lots of work in this area. He has invented lots of algorithm as well, Deutsch algorithm. Peter Shor, he also developed source algorithm, which is a tremendous algorithm. It can break RSA encryption using quantum computer. So nowadays the researchers are building quantum safe, means quantum computer safe encryption algorithms also to make it more secure. And law of Grover also has created Grover's algorithm. It is very fast search algorithm in quantum computing. So yeah, so these are the researchers in quantum area. Well, now why this is exciting, quantum computer? So if we see the complexity level, how this quantum computer solves is very high. So complex problem solving techniques, it can solve complex optimization problem. It can break any kind of encryption if it is not built in quantum computer, with the help of quantum algorithms, then it can break it. Also, it helps in simulation of very critical uh, medicine discovery or any kind of physics or chemistry simulation. It can be used to find out the proper solution. And we can see that the latest quantum chips what are coming in the market, it is faster than the classical supercomputers. Well, now we can see the current limitation of quantum computer is that the error rates is very high. Now we can nowadays the Willow chip in quantum computer has reduced the error rate, and now we can apply it in an industrial solution. So but building this quantum computer or processor is very difficult for but and it is very complex as well. So we are not using this quantum computer in our day-to-day transaction work and all those things. We only now we are keeping it as to solve a complex problem that a normal computer takes years of time. Okay, now to understand this quantum mechanics, we need to understand a double slit experiment. It is very important experiment. In this experiment we can use it either wave or electrons, photons, we can use it. So here we can see that we need to understand how a quantum mechanics behave or quantum physics behave here. So when we are sending a light or photon or water here, so it is going, there is a wall and there is two slits. So when it is going out of these two slits, the water, or it is taking a wave behavior. This is we call interference pattern, and when it hits the final detector or final screen or wall, then it is working as a behaves like a particle. It collapses like a particle. It flows like a wave and it collapses like a particle. So we called particle collapse because in quantum computing this is the word we are using, term using. It is first determine all those in a quantum waves, and then it is collapsing as a classical bits. So when you measure, everything will be classical bits. Now the interface pattern, we can see they can work as a constructive way or destructive way. Constructive means when two waves are coming each together here, it can increase the amplitude, or if one crest meets with a trough, then it will be nullify or it will cancel out each other. So if it cancel out each other, we will see a dark region. If it increase the intensity, then we will see a brighter region. So we have already told that the wave and particle duality. So this is the main principle how it is flowing here. So wave means it is flowing as a wave, going through a pass to this destination as a wave, and when it hits the target, it works as a particle, and we are measuring it. Is it bright or dark or like that? We are measuring it here. Now we need to understand what is the connection between a quantum computing and this double slit experiment. So the quantum particle, like the electron or photon, exists in superposition, meaning it goes through both slits at the same time as a wave, creating an interference pattern similar. So it here, when two particles, when these two slits, when they are crossing here, we are taking it as a superposition. So both the bits, if we consider in quantum computer, both the bits have the same probability here. we call it as a superposition. Now quantum bits also can be in superposition as a 0 and 1 simultaneously, allowing the quantum computers to process multiple computation at once. So this is the similarity between double slit experiment and quantum computing. It holds the same wave particle duality property. The particles behave like a wave initially. When measured, the interference pattern disappears. Now the wave pattern is disappeared, they act like an individual particle instead. Whereas in quantum computing it is also same. It behaves like a wave, eliminating the power of computation. When measured, they collapsed into a definite state, 0 or 1. It is a classical bit. The interface pattern also, it is working as a series of alternating bright and dark bands or region we call, that forms when the wave pattern such as the light or sound overlaps and interact with each other. With the help of quantum algorithms, use quantum interference to enhance certain computational result. So here also we are using the same interface pattern to reach our final result. So we can, this is, we can interfere the wave property, and we can reach our target results, computational results. So these are the similarity of double slit experiment and quantum computing. Well, now we'll see what are different types of quantum computers. Universal quantum computer, and there is another quantum annealer. So in the universal quantum computer, this type of quantum computer uses quantum logic gates and builds a circuit to perform the computation. So there are lots of logical gates are there, like in classical logical gates, classical computer, we are using AND or XOR NOR gates. So here also we are using poly X gate, poly Y, Z gate, all those things we are using. So we'll see it in later videos. Okay, by the help of this quantum logical gates, we are building a circuit. We'll see it in IBM cloud as well, how to build a circuit to perform the computation. But in quantum annealer uses a meta heuristic to find a global minima or maxima depending upon our objective function over a set of candidate solution. So it uses a meta heuristic way to reach our target solution or final solution. It is maybe maximum or minimum. And measurement and observation assigns to the observed variables to a single value. Here in the quantum annealer, in a nutshell, it solves a specific type of mathematical optimization problem. It solves a optimization problem is the main goal of this quantum annealer. So lots of scheduling problem or database transaction scheduling problem can be optimized. It can work as a hardware accelerator. So when a CPU is processing multiple transactions, quantum annealer will observe all the transaction at a single point of time, and it will schedule and it will think all the possibilities in which the optimal transaction scheduling can be done, and it will finally give the result which is the optimum transaction schedule, so that database scheduling will be more faster. So some quantum computer we can see here, IBM quantum systems, these are in cloud, we can use it. Google quantum AI, Google has got the quantum supremacy by Sycamore in 2019, I think. It is that time they proved it faster than supercomputer. Also now recently they have published Willow. It is also very fast, and it has very, now they are focusing on putting it lower error rate. So rather than increasing the number of qubits, they are also reducing the error rates so that the quantum output will be more accurate. Also Microsoft has released Majorana chip. Here D-Wave, we can see quantum annealer, we can use it, wave advantage or D-Wave advantage 2, etc. are there, or NEC quantum annealer annealing system also there. So this is the different types of quantum computers. So in the next video I will explain block sphere and quantum bits that I initially explained, what I have shown you in the bracket notation. So I'll explain it in more details, and how it is, or and what is Hilbert space, I will explain it. Hope you will like this video. Please share with your friends and subscribe my YouTube channel. Thank you for listening. Bye.